Hello and welcome to our first video. This one's going to be over complex numbers, and every number in the world is categorized, just like animals at the zoo. They get categorized and they get put into cages in certain areas. Well, these numbers, we're going to do the same thing with them. So complex numbers are divided into two categories. There are real numbers and there are imaginary numbers. Now, a real number is a number, the only time that a number is not real is the square root of a negative number. So, for instance, over here, the square root of 4, which is 2, is a real number. The square root of 5, which is not nice, but is a little bit bigger than 2, is a real number. Because 2 times 2 is 4, right here, maybe it's 2.1 something times 2.1 something, that is 5. It's not exactly 2.1, but there is a number that if you multiply it by itself, gives you the square root of 5. Now over here with imaginary numbers, the square root of, for instance, negative 4. The square root of negative 4 would mean what times itself is negative 4? Well, 2 times 2 is 4. So that won't work. Negative 2 times negative 2 is also 4. So that won't work. There's no number that you can multiply by itself that will give you a negative 4. Because a positive times a positive is a positive, and a negative times a negative is also a positive. So imaginary numbers, what they really are, is the square root of a negative number. Now there are just as many imaginary numbers as there are real numbers. Because, for instance, the square root of 4, its counterpart in the imaginary realm, would be the square root of negative 4. Square root of 5, square root of negative 5. We don't use the imaginary numbers, though, as often, so I put them over here in a smaller category. Now, the real numbers, they're divided into two parts: rational and irrational. Rational numbers are numbers that can be written as fractions. Irrational numbers cannot be written as fractions. So an irrational number, for instance, would be the square root of 5, because there is no number that when you multiply it by itself exactly equals the square root of 5. The square root of 5, if I type it in, it's like 2.1 and it keeps on going. The square root of 4, however, is just 2, a nice firm number. So a rational number, there are different ways of describing this, but it can be written as a fraction. Also, it either terminates or repeats as a decimal. So if I write the number as a decimal, it's either going to terminate or repeat. So an example of this would be, for instance, 4/7. If I take 4/7, well, that is written as a fraction. The decimal equivalent for 4/7, if I take a look on my calculator, 0.57142857, and then it repeats itself 1/4, so the next numbers will be 2857, and it keeps going on. That would be a rational number. The only time that we will have irrational numbers is the square root of 7, the square root of some number that doesn't come out nicely. Or if we have pi, that's also an irrational number. It's 3.141 and it keeps going. It never repeats, never terminates. There's one other number, e, it's called the natural number, and it's 2 point something, and it keeps going on and doesn't repeat itself also. If we have rational numbers, they break those down, and those get broken down into the integers. So the integers are, we throw away all the things that don't look like this. -3, -2, etc. in each direction. So in other words, we get rid of the things that look like 4 sevenths, or 5 eighths, or 0.23, or 9.3. Just these nice, solid numbers. If we then get rid of the negative numbers, those are categorized as whole numbers. So the whole numbers are 0, 1, 2, 3, etc. And then if we throw 0 away, we get the natural numbers, which are 1, 2, 3, etc. So that's how the numbers are divided out. Let's take a look at it on the back side. Again, they're divided into real and imaginary, and there are just as many real numbers in this area as there are in the imaginary area. It's just that we put those kind of over to the side because we don't use them as often. There are actually just as many rational numbers as there are irrational, but I made this smaller because we don't use them as often. It's far more useful to do the square root of 9 than the square root of 8. The square root of 9 being 3, the square root of 8 being an irrational number that keeps going on. So these real numbers, though, they're separated out if we want to make a Venn diagram out of this in order to view them. If it's a rational number, then some of those rational numbers are integers. Some of those integers are whole numbers. Some of those whole numbers are natural numbers. So it's how far down we can categorize it. If I go back to an animal analogy, it's sort of like saying, is it a cat or a dog? And if it's a dog, it goes into this category. And then if the dog is a collie, then they can go into this. And if it's a border collie, then it can go into this. So it just becomes more descriptive as we work our way in. A rational number, it can be written as a fraction. In order to get into here, you have to be -3, -2, -1, 1, 0, etc. Whole numbers, 0, 1, 2, 3, 4. And the natural numbers, then, we throw away 0, and it's just the counting numbers, 1, 2, 3, etc. So please try putting these numbers in as far as they can go. Categorize them as far into either the imaginary or the irrational or the rational, and go into this as far as you can go with the number -5. Two-thirds. E. Square root of -4. 2. 0. 0.27 pi and 9.8. So please take those numbers, try to put them in there. We'll talk about them in a minute.